Hello student, we are from Devi Mahalakshmi Polytechnic Titwara, Department of Computer Engineering and Information Technology. Semester 3rd, CGR, subject code 22318. In the last chapter, we have studied many display devices, computer graphics, regarding computer graphic basic concepts, the pixels, resolutions, pixels, frame buffers as also, and as well as in the display devices to make a use of these devices to display the objects like a line, circle, polygons, etc. We need some special procedure, but whatever may be the procedures used, the systems is generated the images by turning the pixels on or off, the process in which the object is represented as the collections of the discrete pixels is called as the scan conversion. Now, learning outcome of this video, line drawing algorithm. There are 3 algorithms, but I have explained in only one algorithms, DDA algorithms in this video. And Brenham's algorithms, I will be explaining the next slide video. Okay? The chapter 2nd, raster scan graphics. The chapter is for 18 marks. Now, we will start from the line and line segments. Some definitions of a line. We can specify a point by giving a pair of numbers x, y. When 2 points are there, x and y, and these 2 points are joined together, it's called as a line segment, where x represents the horizontal distance and y is represent the vertical distance. To specify a line, we need to such a points, and every line is described by the equation such as that if a point xy satisfies the equation, then that the point on the line. If the 2 points used to specify lines are x1 y1 and x2 y2, then the equations of will be some equations of creating whenever the multiples x and y coordinates there, then the equations is the y minus y1 divided x minus x1 is equal to y2 minus y1 is equal divided by x2 minus x1. A line in a computer graphics typically refers to a line segment, which is a portions of a straight line that extends indefinitely in opposite direction. It is defined by its 2 endpoints and the slope intercept equation for a line. Y is equal to mx plus b. Here m is equal to slope of the line, b is equal to the y intercept of a line. Slope m is the change in the height divided by the change in the width for any 2 points of the line. The intercept b is the height at which the line crosses the y-axis. We can get y-intercept by having 0, b. Figure shows the line A. The A1 and A2 is the pointer. In first slide, I have told about the P1 and P2, but A1 and A2 is the similar is there. a1 x1 and y1 and a2 x2 and y2. These are the 2 points, and x coordinated and y coordinates are also there. Whenever the 2 points are joined together, that times one slopes are there, one intercept lines are clear, and these lines are called as the line segment. And then y is equal to mx plus b. Here m is the slope, then the there is one more useful form of a line equation called as the parametric form. And the y-intercept b is then found by linking y1 and x1 to the y is equal to 3x plus b. These are the formula. 0 is equal to 3 of 0 plus b. X value is the 0. The types of line drawing algorithms. There are 3 types of them. The DDA line drawing algorithms, brainstem line drawing algorithm, and midpoint line algorithm. But it along our syllabus, we have all explained DDA line drawing algorithms and brainstem lines algorithm. The process of turning on the pixels for a line is called as the line generation or a scan convergence of a line. When we want to draw a line, that means we have to make the pixels on that line to on condition. That is, we have to change the intensity of the pixels present on the line. For this different tasks, we have two different algorithms. I have already told about these algorithms, and both the algorithms are based on the increment method. Let us see the increment method now. To draw a line, we must know the 2 endpoints are there. The DDA algorithms, it's called as the digital differential analyzer algorithm. The digital differential analyzer, an algorithm for the scan converting lines. It is based on the calculating the rate of change of x or y coordinates, that is the delta x or the delta y respectively. For each part of the line, for following holds true. M is equal to delta y is based divided by delta x. Delta y is equal to m delta x. Here the m is the intercept of a line. Then if delta x is equal to 1, that is the pixel is the 1, there delta y is equal to m. That is, for each pixels we move right along the x axis, we need to move down by the m pixels. In pixels, the gradient represents how many pixels we step upwards, delta y, from the every step to the right. Digital differential analyzer is based on the incremental method. The slope intercepts the equation for a straight line. We have learned in the next slide the y is equal to mx plus b, where m is the slope and b is the y is the intercept, and we can determine this value of the m is equal to y2 minus y1 and x2 minus x1. Then for lines with a slope m is less than 1, then lines with a positive gentle slope, we are moving in x direction by uniform steps of the calculating the corresponding y values by using dy upon dx is equal to m. So dy is equal to m into dx. Using this formula, we can represent the integer 0.23, but we cannot now the DDA algorithm steps are here. Accept the two endpoints x0, xa, ya and xy, yb. Then declare the x1, y1, x2, y2 is there. Then find out the horizontal and vertical difference between the points. Dx is equal to xb minus xa and dy is equal to yb minus y. The third is the difference between the greater magnitude determines the value of parameter steps. Then determine the offset needed of each step, that is to generate the next pixels. Loop through these steps time. Then before displaying every point, round up the point to its nearest integer value. And then 6 point, if dx is greater than dy and the xa is less than xb. The program for the DDA line generation. In this class DDA algorithms, the DDA line algorithm functions are used in here. Then the private functions integer x1, x2, y2, y1, y2 is declared. And then the void DDA line algorithms functions are generated. After that, the integer dx is equal to x2, x1 and dy, y2, y1. Then the integer step is equal to abs and abs dx is greater than abs dy, question mark dx is equal colon dy and bracket complete and semicolon. Then float increment and then get coordinates functions are used for taking the inputs from the user. Then enter the first coordinate x1, enter the second coordinate x2, enter the y1 and y2. Similar that. And then a figure show the figure output as displayed there. The line generated from point 1 to point 2. Enter the coordinate starting point of line is equal to 100. And now some advantages and disadvantages of the DDA algorithms. Advantages of the digital differential analyzer. It is a simple algorithm to implement. It is a faster algorithm than the direct line equation. Number third, we cannot use the multiplication method in digital differential analyzer. Fourth is the DDA algorithm tell us about the overflow of the point when the point changes its location. Some disadvantages occurs in the DDA algorithm. The first is the floating point arithmetic implementation of the digital differential analyzer is time consuming. Second, the method of round. Thank you.